In constructor response number 11, the linear unit second question, it's all about three variables to. So question number 3 on the multiple choice is an ideal question to review. Disclaimer, if you're doing this before we've covered matrices, then we will have another option later. But right now, for the constructor response, we're going to have to do it the way we did back in October, whenever we studied this in September, October. That is all algebraically. So I've got a new slide ready to go for that. Thing you start thinking about, you look at each equation that's given and you're looking at what do they have in them. Let's see, the first one has an x and a y and a z, the second one has an x and a y and a z, and the third one has just a y and a z. So that kind of catches my eye. If the third equation is missing an x already, then one strategy to solve this system of equations would be to take the first two equations and put them together and get rid of the x's. So if you do that, if you eliminate the x from the first two equations, you'll have another yz equation that you can pair with the original third and solve. So that's the strategy I'm going to use here. I'm going to take the first two equations and get rid of x. So if this one has a 4x in it, I want the second equation to have a negative 4. So I'm going to erase all my writing so far, but that's the thought. I want to take the first two equations and get rid of x. So I'm going to multiply the second equation by negative 4 so that it immediately says negative 4x underneath the original first equation that says positive 4x. So when I choose to add them, those are going to eliminate. All right, so that's the goal, but we got to continue distributing this negative 4 to the negative 2y, so that'd be positive 8y, negative 4 to the negative 3, that'd mean positive 12z, and don't forget to do it on the other side, negative 4 times 3, negative 12. When we add the equations, we eliminate x. Negative 1y plus 8y is 7y. Positive 1z plus 12z is 13z. And then we add the 2 and the negative 12 and get negative 10. So we can take that, 7y plus 13z equals negative 10, and take our original third, negative 5y minus 4z equals negative 14. And we have a two-variable, two-equation problem solved for y and z. You have choices, elimination or substitution. I'm going to eliminate, and I'm going to focus my efforts on eliminating y. So it's like a common denominator, 7y and a negative 5y. I can turn them both into 35 by multiplying the first times 5, so I'll get a 35y, and multiply the second equation by 7, so I'll get a negative 35y. So the first equation, 5 times 7, 35y, 5 times 13, let's see, that'd be 5 carry 1, 65z, 5 times negative 10, negative 50. 7 times the negative 5 gives me negative 35y. 7 times negative 4 gives me negative 28z. And 7 times gives me 1 carrier 2 gives you negative 91. Add the and that y and 8. So, all right, time to bring the calculator out. 65 minus 28, you get 37z. 37z equals negative 50 plus a negative 91, negative 141. Moment of truth. Hopefully, when you take negative 141 and divide it by 37, fingers crossed, it's a nice number, and it's not decimal, or there's something. I want to check my mental math real quick. I did 7 times 14 in my head, and that's what it was. So you may already been screaming at the video. This should have been 8, sorry. So negative 148. But that was a prime example of how one little mistake can mess up the whole process. So you got to be very diligent when you go back, check your work, or be diligent the first time. So now, fingers crossed, see if we get answer. Negative 148 divided by 37. Fingers crossed. All right, now we're looking more like what it usually looks like. Z is negative 4. All right, but it asks us for x, not z, so be careful. Don't fall for that distractor. So how are we going to find? Well, we got to backtrack and find z and our y first. One of those two equations. Pick your favorite. I like the 7y plus 13z, so I'll take the 7y plus 13z equals negative 10, and I will replace z with negative 4. So I'm using this equation. 7y plus 13z equals negative 10, and I'm putting negative 4 in. So I don't want to make any mental math mistakes anymore. 13 times negative 4 should have been negative 52. So 7y minus 52 equals negative 10. Add 52, and you get 42. Divide by 7, and y is 6. But again, okay, that's not a distractor this time, but it's not what we have. Right now we have our z number, we have our y number, but we don't have our x. Just as a reminder, that's an ordered triple we're creating here. We've got our negative 4, we got our 6, and the last one we need is the one that the question's asking us for, the x value. So we can go back to the very beginning. Any equation that we're given, I like the 4x minus y plus z equals 2 equation. And we can now put our y value, 6, and our z value, 4, in to that equation and find x. So the y is 6, z is negative 4, so that is a 4x minus 6 and a plus a negative 4, so that's 4x minus 10 equals 2. Add your 10, 4x equals 12. Divide by 4, x is 3. The answer is D. So that's a good review problem for system of equations, but the very first step, the most important step, so I do want to scan to it real quick. You want to look at these three equations and think, what can I get rid of? They all have x, y's, and z's. So here's an option. If you added them, the y's would eliminate immediately. So you may want to start your strategy around take the first two equations and get rid of y. If you do that, you're going to have to use the third equation that has a 2y with one of your original first or second separately and get rid of the y again, so that then you'd have two x z equations. Again, we're getting into territory that I really probably should be here to help guide the discussion if you get stuck, but hopefully that's enough to get you going on that for the most part. If you need to go into sequences and series, those videos are available too, and that one may be a little more familiar than three variables, three equations.